All right, so we're moving on to the more technical session of the day, actually taking a deep dive into the different work packages of Digital Roads and explaining what it is exactly that we are doing, okay? Now, there is a ton of information here. It's the definition of death by PowerPoint. But having said that, not everything is there for the purpose of us presenting it. A lot of that's there for us to share it with you later. So if you want to go back through the details, they're all there in the slides for you, okay? So starting with Work Package 1, Digital Twins. What the team has decided to do is start from the 2020 vision of national highways, and then through that show you how the entire program is directly related with the various ends and bits of that vision. Specifically for Work Package 1, these are the 3 key points identified by the team where we as a team hope to have significant impact. The first one is full digital integration with the supply chain, enabling real-time data sharing to maximize efficiencies. I mentioned that before, that usually the problem is that the inefficiencies are in the links. If we can sort that problem out, we'll have significant improvements on every aspect. Digital twins, of course, consistent strategy across the whole supply chain, and the network-wide digital twin used to better control the network and flow. I think all of these are directly related to what we're doing. You remember the loop I showed you earlier? This is the focus of the first part of the presentation. How do we plan, design, construct, maintain, and operate digital twins for highways? Within that scope, that's the team in a bit more detail than what I presented before. And we, of course, are not done yet. We're still recruiting additional individuals. Can I ask those who are in this team to stand up just to identify themselves? We have Jürgen, Lilia, we have Zane, we have our friend Bakshi, and Wei Wei. You're there as well. And where's Diana? Oh, there she is. Okay, thank you. Right, so if you want to talk to them later on, please do. Okay, they're with us in the room. Now on to the technical side. We've heard a lot about digital twins from just about every direction. It's a topic that's really capturing the imagination of where the digital side of our industry is going. And that's because of the promise. What can digital twins actually give us? And the promise is, as always, incredible. Like, it can do everything. It can help us effectively improve across all key performance indicators: cost, time, quality, safety, sustainability, resilience, and so on, by improving the way we manage information. The reason for that is what I call the typical engineering sequence loop. The thinking that for just about everything we do, even in our private lives, we do something in the real world, we monitor what it is we're doing, that produces some data, we then model that data into knowledge. We use that to simulate insights, and then we apply those insights, we act to produce some results on the physical asset, and so on and so on. I think that's a very familiar loop for everyone. Now, for a very simple task, like walking, I still do that, but it's such a simple task that I've pushed the whole process into the subconscious. I don't even need to think about it. Same for driving. But for a very complicated task, like building a complex piece of infrastructure, maintaining it, I can't possibly fit all of that loop in my head. That's where we use software. That's where we leverage the capability of the digital space to do all of that in a more reliable way. What digital twins allow for us is the ability to do all of these functions in an integrated system, to bring all of these pieces together in a single puzzle. So why digital twins? Well, first and foremost, we have a constant increase in asset complexity. The best example I like to give is Empire State Building, built 150 years ago. Back then, we were able to build a floor per week. Now that's not possible. Well, why is it not possible? Well, that's because back then they were not building air conditioning systems. They were not building all kinds of other systems that we put in buildings today. They were a lot simpler. By increasing complexity on our end, that has an impact on the program, and that's why our productivity is also suffering. How can we manage this complexity? Well, by increasing automation with the help of digital twins. The other thing they do, as I mentioned before, is combining product and process, combining modeling, simulation, and monitoring, the loop I showed earlier, in the same platform. But that, of course, has consequences. There is the negative consequence, which is you have a very complex outcome, the digital twin, which tends to be very expensive to design, to construct, to maintain, to operate. And to a large extent, that's why we don't have digital twins today, because it costs a lot to do all of that with them. But at the same time, there is value. A rich model that's integrated provides significant value, especially if it's flexible and able to serve multiple purposes. We also see digital twins as something that will have to be federated. We are past the point where we can control everything in a single model. We have to get into a world where now you have to have different databases and systems working together, and we have to plan from that perspective. A model that is extensible and future-proofed. This comes back to the huge difference between the life cycle of technology versus the life cycle of our assets. I mean, think of embedded sensors in concrete in Thames Tideway. No offense to anyone that does concrete in here today, that made no sense to me. Why would you embed something that has a life cycle of months, years, maybe 5 years at most, on an asset that's built for 150, 200 years? You'll get maybe a tiny bit of value during the construction phase, that's it. You have to have other ways of capturing that value. You have to have a way to update your technology over time for the same asset. And of course, scalability, because without scalability, we can't work with these models for long term. The value of a digital twin is better decisions, faster. Also, faster refresh rate, so you can have more trust in the information. The opposite example to this is, let's say, the digital twin of Helsinki or other cities. Many examples that cost a lot of money, going to a consultant that built the model, and then in many cases, not all cases, that data is not updated anymore. It was just a one-off, looks very good, pretty pictures, but then after that you can't quite use it because if the data is not up to date, you cannot trust the data. So you have to have a mechanism to continuously update the data to get the value. It has to serve multiple processes because that's how it gets the value, right? The more processes, the more value I bring, and more automation, leaving the high-level decisions to humans and allowing us to take low-level decisions and handle them automatically. So then if digital twins are so great, why aren't they as ubiquitous as physical twins, right? Some of that is because we understand the physical twin, the asset, as a product and as a process, but we don't have a full understanding of it at the digital twin level. We don't quite have a good vision of what is a digital twin product and the associated processes. At the same time, the owners have experience of the value of physical twins, but not so much the value of a digital twin. They haven't quite used it to an extent where they can understand that value and bring it back into the business. And unavoidably, vendors are looking to catch up on that wave and oftentimes enhancing existing products and calling them final solutions when they're not in fact final solutions. We have a lot more to go to reach those final solutions. So this is how we see digital twins. The example I have here is think of let's say a child standing in front of a lake. The child is the physical asset. The reflection on the lake is the digital asset. So you have here the physical product and process, and here the information volume. And things are plotted here on a timeline. So at conception, when we start the design of a project and the planning processes, that's what's happening here. Design processes that produce these two things over time, which is product and process information of the design phase. Moving on to the construction phase, I start constructing things, for example, prefabricated parts, bringing them to the site. Eventually, I reach the winning phase. I leave the mothership and I get on to the site and start building. And I have my child physical twin that grows from nothing into the mature adult digital twin, while at the same time I'm producing construction phase product and process information. And likewise, once you get into the adult physical twin stage, you have operation processes that are producing operation phase product and process info. All of this is the digital twin growing over time. And just to explain that in line, let's say with a existing technology, this little yellow line is a BIM file. Okay? It's the as-designed file with as-designed product information. If you're very lucky, you might have a design status model with the as-designed process information. Even more, you might be able to get an as-built static model at a certain point in time, giving you the construction phase product information, or a project status model giving you the process information of the construction phase. Even when we have all of these, we don't have them in the same system. And they don't talk to each other. And they don't exchange data with each other. So we haven't even gotten to this point where we can combine these things across. But even that wouldn't be, in my view, the full potential of a digital twin. The full potential would be all of this. All the information produced about an asset over time, including changes that we've made, so that if later on, during the operation phase, we discover that something happened and something went wrong, we can then go back in time and see all the changes and all the decisions made that led to that fault in the end. And that is really important. That's what makes a huge difference in getting knowledge out of all the work that we are doing. A few more things. I promise I won't spend too much time on this, to highlight that digital twins are made with information, not raw data. Our ambition is not to keep raw data. Okay, raw data has a very low information value. What we want to do is get processed data, information, converting that into knowledge, converting that into insight. That's what actually holds value. And also to understand the processes that service a digital twin, the planning processes, the design processes, construction, maintenance, and operation. To explain a bit more about this, because it's directly relevant to the work package, by planning we refer here to understanding the scope of the digital twin, the feasibility of a digital twin project, and the costs, just like we would for a physical twin. By design, we're referring to deriving the digital twin asset class. Think of the asset class hospitals or asset class schools, right? And then by construction, we mean populating that class to create a specific asset instance. This school, this hospital, with the specific measurements and dimensions. By maintenance, we're referring to updating that instance over time, making sure that all the values in there are current at varying sampling rates, of course, per attribute. And by operation, we are referring to how then this digital twin services all the processes that you will see in Work Package 3 of this graph. We've been working on this for a very long time. This is just some videos and pictures from projects we've done over the years, exactly in that space, on how we automatically create digital twins of bridges, of industrial facilities, how we then bring the same thing for roads, capture condition information, bring it back to a digital twin, and how we then leverage that information, visualize it, and get people the ability to get value out of that data. We've done a number of projects with this. I won't bore you with all the details on this part. I think I only have one example to show from a student who's here in the room, and he just gave me the video. Maciej, are you here? Yeah, there he is. On how we get the very first phase in the process sorted. This is data from a month ago. Okay, and you have this music on top as well, right? Right, so this is a device he's built that combines a small laser scanner, an RGB camera, as well as a infrared camera. And Maciej, I apologize, but I'm going to turn the music off.
Now the best part started, actually.
Right, and what this is doing is showing you how we can synchronize that data as we are collecting it over time, and the ability to measure in real time how much we trust the information. What is the error we're capturing? And by looking at that error, we can then make decisions that perhaps, because this is all red, I need to go back and close the loop, right? And by closing the loop, I now have more trust in my data, and I can stop scanning when I'm confident that everything there is in fact just as expected. Anyway, I'll share with you this presentation. You can watch the rest later, but I know we have to rush. We have a lot to cover. Within that ecosystem, we are working also on a number of other projects that are directly relevant with this one as well, such as our CBIM grant, many students of which are sitting in the room today, helping us generate geometry, enrich the product, model the process, and then leverage that for the case of buildings. Our BIM2Twin grant that looks at how can we do construction better with digital twins, how can we monitor progress, quality, and other aspects leveraging digital twins. Our Omicron grant, that's very relevant. I apologize for the name, by the way. We did come up with that acronym before the Omicron variant. So now we have to apologize for it forever. Again, looking at how we can inspect roads, bring that into the road digital twin, make decisions, and then drive that into interventions that help the roads. And also to mention some things about our centers and facilities. I'm actually part of the Langeroog Center for Construction Engineering and Technology, and our focus is policy and thought leadership, research, and education. We do quite a lot of work within the center. Beyond that, I have a picture here of our construction IT laboratory. You're very welcome to visit the lab, by the way, tomorrow at the end of this event. If you're still interested, I know it's a Friday afternoon, so you don't have to do it. But if you are interested, I'd be happy to give you a tour of our facilities. And on to what we're actually doing in this grant. For Work Package 1, like I said, we're trying to plan and design digital twins. We're trying to construct and maintain them, and then to operate them. For the first task, we're looking at, first of all, capturing user and data requirements to understand what it is we want to find, and then deriving the foundation data model, the reference data library, and integration cloud architecture in line with CDBB's information management framework to allow us to create the data structures necessary for them to populate them later on for roads. The deliverables for that is our Highways Digital Twin Information Delivery Manual and the Highways FDM, RDL, and IA report that captures those things in detail. We have an extensive methodology of how we're achieving that. I don't want to bore you with all the details, but what I do want to highlight is that across all of these tasks, there's a number of areas here where we can use your help. Okay? And we will share these slides with you, and we hope that we'll use that as an opportunity to start discussing, communicating, finding ways to get your input into the process. Across board, you can see all of these pieces of information as it goes throughout all of these tasks in order to deliver the IDM and all its details, and later on the data structures and cloud architectures. Same thing for the second part. You can see again the constant need for interaction with the industry. And this is why it's a prosperity partnership. This is why it's not just a theoretical grant, right? We need to work with you to achieve all of these tasks as we go along. And it continues on. I mean, again, there's a lot of information here, but I don't think we have the time to cover the details. Again, I'll share these slides with you in order to produce this outcome. For constructing and maintaining digital twins, our focus is on matching objects and then generating or updating the digital twin over time. But also very important, of using legacy data, because we can't ignore the fact that we already have a lot of quite useful data stored in very different places. How do we bring that on board? How do we get value out of that? That's a very important question. The deliverables is a prototype that achieves the first, as well as a prototype that achieves the second. And again, you'll see a number of tasks to achieve that, and significant participation from the partners, as well as the other work packages, right? You see here some tasks referred to, for example, from automation and robotics, to help us achieve those tasks. Same for fusing legacy data. You can see again the same structure. The last part, operating the digital twin, we're looking at the interaction phase. How do we speak to humans? How do we speak to machines? On one side, if I'm directly speaking with machine learning, with automation and robotics, what's the right language? What do digital twins need? What's the right communication protocol? And likewise, if I'm talking to humans, how do I present the information to make sure they get the most out of it? These are things we have to understand as we go through that process. And that's why you see the tasks here: Highways, IoT, DT, enterprise cloud communication, digital twin to data visualization environments communication, and then as a deliverable, the appropriate communication prototypes taking us to that direction. And again, you see the same thing, a lot of tasks with significant need for support from the other work packages with whom we are communicating with. This is work that's directly on the arrows of that big circle I was presenting earlier, as well as participation from our industry partners as we go along all of that. And your typical Gantt chart at the end of the process, at least for the first half of the project. Okay? Quite a lot of work to be done. Quite a lot of work. We definitely need your help. That's it for work package 1. Are there any immediate questions before I pass to work package 3? Yes?
Yeah, well, pilots are efficient. Which pilots are efficient?
What we're hoping to achieve is to use, first of all, National Highways data sets, which we have received quite a lot of, in fact, thanks to Michael Ambrose, who's in the room, right over there, to create an initial prototype using their data sets, and then as a second phase, pass the outcomes of that into work package 5, whose scope is to create the platform that brings the pieces together. At that stage, Tim will present to you later of how we will plan to validate all of that in real assets.